So far we've talked about how to do future value and present value when there is a single investment and then that investment grows over time. But in that context, in the context of what we've done so far, in all of those examples, the person who invested the money didn't do anything else between the initial investment and the final date when they would withdraw the funds. That is, they didn't add anything to it, they didn't take away anything from it. And in reality, it doesn't always happen like that. And in fact, how do people usually invest over time? Well, they don't do it all at once. Typically, people will invest a little bit at a time. And so, how do we find things like the future value or the present value when there's not just one cash flow, but there's multiple cash flows? That's what we're going to start looking at now. And we're going to begin with the concept of annuities. Now, first of all, let me clarify something. The word annuity does refer to a particular type of product that life insurance companies offer people as a part of their long-term planning. That is not what we're talking about here. In this context, an annuity is simply a repeating stream of cash flows. And in this stream of cash flows, it's the same amount that is either paid or received every single period. And there aren't any periods skipped either. So anytime you've got a series of cash flows that happens every period and it's the same amount every period, then we call that an annuity. There are two varieties that you're looking at here. One is an ordinary annuity where the payments occur at the end of every time period. And then there's an annuity due where the payments occur at the beginning of each time period. There's just a slight difference between the two, but it does matter a little bit. It affects the present value and the future value a little bit based on the timing of those cash flows. Most of the problems that we're going to work are ordinary annuities, hence the name ordinary. That's the usual type that we'll see. As an example of an ordinary annuity, think about the way that people repay their car loans or house loans most of the time if it's on a fixed rate. They take out the loan and then about a month later their first payment is due. The first payment's not due immediately, most likely. It's going to be about a month or so before those payments begin to be made. And an annuity due, an example of this might be, let's say somebody won a lottery prize or a game show prize, something like that. Maybe they won $1 million. Well, typically what you'll see is they don't get $1 million right away. They get something on the order of $40,000 a year for a total of 25 years. That is an annuity, and usually it's set up as an annuity due because they go ahead and make that first payment to the person immediately. But we'll learn how to find future value and present value for both types. We're going to begin with solving for the future value of an ordinary annuity. So what I want to know is if we have a 3-year ordinary annuity of $100 per year, what is the future value assuming you've got an interest rate of 10% per year? Well, I want to back up to a previous slide because this is actually illustrated on one of our timelines. If you'll take a look at this timeline, this actually is a 3-year $100 ordinary annuity. Now notice that there are 3 separate payments of $100 per year that is received by the person who owns it. So how do we find its future value? We cannot simply use the good old future value formula that we knew from before because that was for one cash flow only. So how do we find the future value of a stream of 3 cash flows? Well, the good news is you sort of can use that formula that you already know because you can treat each of the 3 cash flows as a separate entity, and if you'll just apply the formula 3 times, then you can get the future value, just breaking it down like that. Let me show you what I mean. Okay, I'm going to get a graphing calculator up here so you can sort of see how the calculations are going to go. And we'll get back out to our main screen. I'm going to find the future value of each of these $100 payments and add them up. When I'm doing future value, I usually start over here on the right side. So this $100 at year 3, how long does it have to sit there and collect interest until the end of the timeline? Well, that's kind of a trick question because the answer is no time at all. It is put into the account at the end of year 3, and therefore it has no time to collect interest. So what is its future value? It's simply $100, nothing more. Okay, then we're going to add the future value of this. Okay, what about this $100? Well, it has a year to grow at 10% and become, a greater amount of money. So how much should it grow to? Let's find out. Well, in this case, we are going to use our future value formula. We're going to take the $100 and we're going to multiply by 1.1 to the power of what? Well, actually just 1 in this case, because it has 1 year to earn 10% interest. And by the way, the 10% is the reason we have this factor of 1.1. I'm taking 1 plus the 10% interest. Okay, then let's look at this other $100, and it actually has 2 years to sit there and grow. So for it, I'm going to take the 100 times 1.1 to the power of 2. So I'll square that. And what do I get? $331 altogether is the future value of that annuity. And actually that's true, because if you wanted to do just kind of a brute force method on this calculation, you could figure it out like this, although I don't encourage this for most of the problems that you would work, because it would take you a long time for multi-year problems. Let's say I give you a 10, 20, 30-year problem. This would take a lot longer. But we can prove that answer is right because let's say the person put in $100 here. Okay, they've got $100. That's great. From here to here, year 1 to year 2, it's going to grow at 10%, and therefore it's going to become 110. Okay, great. Well, at that point, we're going to put in our second $100. It's going to be 210 in the account right there, and then that's going to grow altogether at 10% for another year, giving us 231, and then you put your final $100 deposit in, and surprise, you end up with $331. So yes, it actually is the correct answer. Okay, the problem with both of the methods that I just illustrated is that they might take you a while. For a 3-year problem, that's no big deal, but for a 20-year annuity, it's not that it gives you the wrong answer. No, if you apply the method correctly and you keep doing this, then yeah, you can get the future value even for a 20 or 30-year annuity, or however many years. The problem is you'd like to have a shorter way, if at all possible, and there is a shorter way. Okay, one way that you can do it using a mathematical formula is like so. This is actually the future value of annuity formula. And what you do is you take the periodic payment, which is $100 in our case, and in fact, as we do that, let's go ahead and just get our calculator up so you can see what's going on. We're going to take the $100, and then we're going to multiply by what? Well, up here on top in the numerator, I've got 1 plus I to the n power minus 1. So that's going to be 1 plus 10%, so it's 1.1 to the power of 3, and I'll go ahead and subtract 1 from that. Then you've got to divide the whole thing by I. And since we're using a formula, we're going to put that in decimal form. I'm dividing by 0.1. And of course I do get the answer I'm supposed to get, which is 331. Another way that you can sometimes solve a problem like this is to look this factor up in a table. There are some textbooks and there are some other sources where You can look up future value interest factors for annuities, and you can just look up 3 years, 10%, and the table will tell you that the factor is 3.31 in that case. Multiply 3.31 times the payment of $100 and you'd get the 331. I don't encourage people to rely on that too much, because the problem that you can run into with that approach is that the tables can never give you every possible interest rate. They may give you 10% for 3 years, but what if you needed 10.25%? That may or may not be on the table. So, or what if you got a number of years that was a little bit higher, but it was kind of an odd number? Again, you could run into issues there. So knowing the formula is a good thing, if at all possible. There is also a calculator shortcut to this type of problem, and here it is. Okay, at this point I've illustrated how to do this on a graphing calculator and how to do so on a TI BA2 Plus. So I'm not going to go through exactly which buttons to press again, but you can put in 3 for the number of periods. You can put in 10 for the percentage interest rate per period. You'd put in 0 for the present value, because that refers to a one-time lump sum cash flow today, and there isn't anything like that in this problem. There's no money that we begin with at the beginning of this investment process. Now, as an aside, if you did, like let's say that this person already had I don't know, $500 in the bank to start with, or in this account that earns 10%, then you would have gone ahead and included that as the present value with a negative sign on it. And in fact, you do have a homework problem where that's the case, where somebody begins with some money already there, and in addition they're making payments each period. And in that case, both numbers would have the same sign, and the amount you begin with would be present value. But we don't have that in this problem. There's no initial amount in that account. So then we have payment, which we haven't used this function yet, but it's not difficult. Payment refers to something that recurs every period. Okay, so it's a cash flow that occurs every single time period on the timeline. So either at the end of every period, which is the case here, or sometimes at the beginning of every period, which we haven't talked about yet. And since we're investing that amount, I'd put that in as a negative number, and then you compute the future value, or solve for the future value, and you'll end up with $331, which of course is the amount that you're supposed to get. Okay, so that's how to do the future value for an annuity. How do we do the present value for an annuity? Because that's important as well. In fact, some people might argue it's more important for some of the applications that we're going to see later on. We're going to look at the same ordinary annuity that we were doing before. Let's go back to it. So same timeline, except now we're thinking of it in a different context. We're not compounding forward in time. We're not investing this amount going forward and seeing what would be there at the end. Instead, we're finding what would be the present value. In other words, let's say you had some kind of bond that promised to pay you $100 a year for 3 years. And let's say that a fair rate of interest on that bond was 10%. Okay, so what would the present value of the bond be? What would be a fair price to pay for it today, so that in fact you do earn a 10% rate of return getting these 3 cash flows? Alright, well again, you can take a step-by-step, one-by-one approach here. And it's important to understand what's really going on, and the fact that yes, you can do this. So if I want to take the present value of just this $100, okay, just the first one, then how would I do that? Well, we should know the present value formula for just one cash flow. That's going to be the $100 divided by that simple factor, okay, 1.1 to the power of only 1 in this case. Okay, what about the second $100? Well, the present value is going to be $100 divided by 1.1 squared, right? Okay, it's 1 plus the 10%, so 1.1, and it's to the power of 2 because it's 2 years in the future instead of just 1. Okay, then we can add 100 divided by 1.1 to the power of 3 because that third cash flow obviously is 3 years in the future, and it's still that same 10% interest rate we're using. We do all that and add it up, and we get 248.69 approximately. 248.69 is the present value of all three of those cash flows put together. And that's as good approach as any. And in fact, you can do that on the TI BA2 Plus. Let's say that I clear all this out and I go through the same exact process, okay? 100 divided by 1.1, and then I add 100 divided by 1.1 squared, and then I finally add 100 divided by 1.1 to the power of 3, and of course I get the answer that I'm supposed to, which is the same 248.69. So looks like we're on track as far as that goes. There is a formula. Actually, we're going to get to the calculator solution here in just a second, but there's a formula that you can also use to solve for the present value of an annuity. So what I'll point out first of all is that you can sort of take advantage of the good old present value formula from up here, right? This is the present value formula for a single cash flow, and once you've already found the future value for the annuity, that is an equivalent single cash flow at the end of the timeline. So you could use that if you already knew the answer of 331 for the future value, then you could just divide that by 1 plus I to the n. So as an example here, I could take the 331 and divide by 1.1 to the power of 3 and get the answer that I was looking for. Now if you don't already know, then I guess one way would be to go ahead and find it using the future value formula and then divide the answer by 1 plus I to the n. The approach that I use most of the time when I need to rely on the formula is this. Okay, I'll take the payment and I'll multiply by the present value interest factor for an annuity. And it looks a little bit complicated, but honestly, once you've cranked through a few problems using the formula, it's really not too bad at all. So here's how I would probably go about that for this problem. I would start up here in this numerator and I'd say 1 minus 1 over 1.1 to the power of 3, because that's what's going on there. 1 minus 1 over 1 plus I, which is 1.1, to the power of 3. So I got that number. Then I can divide the result by the interest rate of 0.1. Then I usually, I come back in and I multiply by the payment, which would be 100 in this case. Again, predictably giving me the same answer that I had before, okay, as it should. So that is another method. And then of course, another method is to use your calculator shortcuts. So you could go in here to Apps, Finance, Time Value of Money Solver. You could put in 3 for the number of periods. You could put in 10 for the interest rate percentage per period. And then you could put in, it would be 0, well, you're solving for the present value, so we're not going to put anything there yet. On the payment, we're going to put in 100, and then we're going to put in 0 for the future value, because you know that future value would represent a special one-time cash flow at the end of the timeline, and there isn't anything extra that you get over and above that $100, so we'll just leave future value at 0. Then we put the cursor on present value and we click alpha solve. and we get 248.69 just like we were expecting. Over here on the TI BA2 Plus, of course, we could say second clear time value of money to clear out all these registers. We would put in 3 for the number of periods. We would put in 10 for the interest rate per period. We would put in 100 for the payment per period, leaving future value at 0. It was already cleared out. And then compute the present value, and we end up with, not surprisingly, 248.69. Okay, so we've seen a number of ways now that you can get the present value for an annuity. And it's good to see that you can work the problem more than one way. Okay, I do want to show you something here about annuities due. Remember what we said? There are 2 different types of annuities. Ordinary annuities have the payments occur at the end of each time period. Annuities due have the payments occur at the beginning of each time period. That is the only difference between them. Now, it does make a difference in the future value and the present value a little bit. And the difference is this. Because the payments occur 1 period sooner in time, 1 period earlier for each one of them, it basically bumps everything up by a factor of 1 plus I. Okay? Bumps everything up by this factor of 1 plus I. So if you want to know the future value for an annuity due, and you already know the future value of the ordinary annuity that would otherwise be equivalent, or you could figure this out because we've already shown how to do the future value of an ordinary annuity, then that's great. You can take that answer and simply multiply it by 1 plus I. So take your 331 that we calculated earlier times 1 plus the interest rate. There's no exponent there, okay? Just 1 plus the interest rate, 1.10, and you get 364.10. So that works pretty well. And for present value, it's the same thing. You take the ordinary answer, we got 248.69 for the present value of the ordinary annuity. We multiply it by this factor of 1 plus I, that's 1 plus the interest rate, and we get 273.55. That would be the present value if this had been an annuity due. That's probably the way I'd recommend that you work these problems when you have an annuity due instead of an ordinary annuity. So what would you do? Is there a calculator shortcut for this kind of thing? Yes, there is. I'll show you how to use it, but then I'll give you a caution about something you need to remember if you're going to use the calculator shortcut. Okay, so let's go ahead and get the BA2 Plus up on the screen. You can change the setting so that the calculator assumes that the payments occur at the beginning of each time period instead of the end. So you can do so by pressing second and then begin. Right now, the assumption by default is that the payments happen at the end of each period, like an ordinary annuity. But you can switch that. You can do so by pressing second set, and then get back out by pressing second quit. And you'll see there's a little friendly reminder in the corner of the display, BGN, that says, hey, you're in begin mode. That's annuity due mode. So you can go ahead and now, you don't even have to change anything in here. You can just go ahead and compute the present value in this mode, and you'll get 273.55 like we said on this slide. And you could have done the same thing had it been a future value problem as well. What about on the TI 83 or 84? What about these graphing calculator models? You can go down to the bottom of this time value of money solver, and here you have the option to switch it from end mode to begin mode. So use your right arrow to go over to begin, press the enter key, and now you're in begin mode or annuity due mode. Set your cursor back on the present value, press alpha solve, and you'll get a different answer. You'll get the answer for an annuity due. Okay, so that should be pretty straightforward, but I do want to caution you about one thing here. After you're done, change it back. Don't forget, because most of the problems you work in this class will be ordinary annuities. So change it back to end mode as soon as you are done, otherwise you'll forget and you'll be working other problems and you'll be getting wrong answers on ordinary annuities because the calculator's in the wrong mode. How do we change it back? It's easy. On the graphing calculator, just set your cursor back down on end and push enter, and you got it. On the BA2 Plus, you get out of this mode the same way you got into it. You press second begin, okay, and then second set. Now we're back in end mode, and then back out to the main screen by pressing second quit. And that is pretty much how you do it.